Hey guys, um, today we are going to start doing equations, solving equations. There's two types of equations we're going to solve over the next 2 days. We're going to do exponential equations, and then we're going to do solving log equations. Okay. Um, Now, exponential equations are obviously equations that are going to have x in the exponent. Log equations are going to be equations that have logs on them. Okay. Um, and they go hand in hand because basically, except for this first example that we're going to do, um, to solve an exponential equation, you use logs. To solve log equations, you use exponentials. All right. Um, so to do exponentials, all right, like this first example is, there's basically the first way without using logs is to see if you can make the bases the same. What do I mean by that? Well, the basis in this problem, you have 2 to the x squared equals 4 to the 3x minus 4. The base we're looking at is 2 and 4. Is there any way we can rewrite one of these so that they're the same base? I was 2, we can't do anything to, but 4 we can rewrite as 2 squared. Okay, so we rewrite 4 as 2 squared, and then we remember the rule, power to a power. What you do is you multiply those, right? So you end up with 2 to the x squared is equal to the 6x minus 8. Okay. Now, once you have the same bases, the only thing you care about is that the exponents are equal. If the exponents are equal, then the equation is equal. So you have to just solve for the exponents. And that's what we have here. It's basically like, all right, forget about the bases and just set the exponents equal to each other. So that's where you get x squared equals 6x minus 8. Now this is a normal quadratic. Bring everything over, you set it equal to 0, and then you factor, you get x minus 4, x minus 2, and you get x equals 4 or 2. You get 2 possible answers. All right. So if you can make the bases the same, you do make the bases the same. All right. Now, there's going to be a lot of examples where exponentials where the bases you cannot make the same. All right. For instance, if you look down here, 2 to the x equals 10. All right. Obviously, 10 can't be rewritten as anything. All right. So in this case, all right, this is where you're going to have to use logs. All right. We can't make bases the same. So we're going to take the log of both sides. Now, you could just put log and use base 10, and that's fine. Sometimes it's easier to use the base that matches the base of the exponent. So for example, all right, since we have 2 to the x and 2 is the base of one that has the exponent, we can add log base 2 to both sides. So log base 2 of 2 to the x equals log base 2 of 10. Okay? If you did not do that, it is also okay. Let me choose a different color here. If you just put log, which is base 10, if I did log of 2 to the x equals log of 10. All right, and I'll show you the difference in a second. All right. So if we remember our properties of logs, all right, what do I do with exponents? Exponents get moved to the front. All right. So the exponent is freed, right? We're going to move it to the front to come down as a coefficient. Now, the nice thing is because we use log base 2, that's the reason this is nice, is log base 2 of 2, whenever you have the same number here as the same base, because remember, if I evaluated this, 2 to what power gives me 2? It's 1. This is just equal to 1. So I'm just left with x equals log base 2 of 10, and there is my answer. Right, log base 2 of 10. All right. So logs enable us to solve. You're like 2 to what power gives me 10? Well, it's some weird number. Well, that's the number, log base 2 of 10. Right. If you were to put that into your calculator, which you can, All right, there's a log button there. You just put log base 2 of 10. You would see you get some decimal answer, some number. And if you put 2 to that power, it'd be roughly 10. Now, just to show you, if you were to do log of 2 to the x equals log 10, we would do the same process, right? The x would come out front, and it'd be x log of 2 equals log of 10. And to solve for x, I would need to divide it by log of 2. And I would get log 10 divided by log 2. Remember, there's no base here, which means it's base 10. If you were to put this in the calculator, guess what? It equals the same thing as this. All right? Either way is going to be acceptable, whatever one you like better. All right. All right, so for our next example. So for this one, all right, we have, oops. All right, we have e, all right, e to the x. So if we have e, all right, we instead of taking just the log, we're going to take the natural log of both sides. All right, we're going to take the natural log. So we're going to get the natural log. All right, we're going to get the natural log of e to the x equals the natural log of 20. And the same process happens. We're going to move the x out front. All right, so now we're left with x natural log of e equals the natural log of 20. The natural log of e, you have to know this. This is equal to 1. That's why there's a cross out through it. It's just equal to 1. So then we're just left with the final answer of x equals the natural log of 20. Right? X equals the natural log of 20. All right. All right. 4. Now, this one's a little bit different because we have 2 to the x minus 1 equals 3 to the x. Obviously, you can't make 2 and 3 the base is the same. So we're going to take the log of both sides. And you can't pick, and also the x, there's in both exponents, okay? So you can't just put log base 2 or log base 3. So in this case, this is where just put log, all right? Just use log. So log of 2 to the x minus 1 equals log of 3 to the x. Once you put the log of both sides, you then move the exponents to the front. All right, so the exponents are freed, and we're left with x minus 1 times log of 2 equals x log of 3. All right, we're going to distribute that. So it's x times log of 2, which is x log of 2. 1 times log of 2 is obviously log 2. Distribute the negative. So we're left with this equation right here. Okay, so I have 2 terms that have x's in them. So we move all the x terms to the left, all right, to one side. All right, and then we're going to move this over there. All right, so we end up with x log 2 minus x log 3, move this over, equals positive log 2. Okay, we then factor out the x because both these terms have an x in it. We take a GCF, we factor it out, and we factor out the x, which leaves us log 2 minus log 3 equals log 2. And then we just divide by this, giving us log x equals log 2 divided by log 2 minus log 3 on the bottom. These do not cancel. There's your answer. Okay, so to recap with exponentials, if you can make the bases the same, then you do that. Forget about the base, set the exponents equal to each other. Nice, easy problem. If you cannot make the bases the same, all right, logs make it. You take the log of both sides. It enables you to figure out problems like this where you can't. This is not a number that you just know. All right, so you then take the log of both sides, bring the exponents up front, and then solve for x from there. So that's how you solve exponentials, by taking the logs. All right. Next lesson, we'll talk about solving logs, which you're then going to see is by taking exponentials. Okay, so we're going to do equations this week. All right, and then we will end up taking your final assessment will be next week, and that'll be everything to do what we've done the last couple weeks with logs. All right, hope you guys are staying healthy, and I will talk to you soon.